I'm going to start off by kind of going through a few of these right off the bat and showing just some ways to solve this. For this first one here, that's the triangle sum theorem, which we ended up with 65 plus 57 plus the question mark is equal to 180. Solve that, we ended up with 58 degrees. So you can pause that and look at that. This one, whenever you see this symbol right here, that's 90 degrees. So you have 90 degrees. I use the idea that, all right, if I already have 90 degrees, these two angles have to be equal to 90 degrees as well. So 40 plus the question mark is equal to 90 degrees. I got 50 degrees in that case. Same thing here, 20 plus 30 plus the question mark, triangle sum theorem. Same thing for number 4, triangle sum theorem. 85 plus 50 plus the triangle is equal to 180. And that would be 80. I was thinking about the answer. Now, the first of the interesting problems would be, how do I get to here? Well, in order to get to there, I probably need to label this and say that's an exterior angle. If that's an exterior angle, then if I know these two angles together and can add them, I can find out the value of the question mark. So, by going 137 plus x, which was right here, that was equal to 180 degrees. Subtract the 137, I got 33 degrees, and got our answer. Now, in number 7, if I want the question mark, I use the triangle sum theorem first to figure out what this angle is, because this angle is congruent to this angle because they are vertical angles. And so I set up my triangle sum theorem, and I'm good to go with that. Now I'm going to skip to some problems that have been causing some people some difficulty. Take a look at number 10, for example. Now, to get to this angle, the first thing I have to do is focus on the first triangle here and get an x value here. So I need to set up 60 plus 65 plus x is equal to 180 for my triangle sum theorem. So this is 125 plus x is equal to 180. Subtract 125. 125 from both sides minus 125. X is equal to 55. So now this is 55 degrees. And the only way that I can get into the second triangle is to see that these three angles together are going to form a line. So 50 plus 55 plus x is equal to 180. So that's 105 plus x is equal to 180. Subtract 105, 105 from both sides, 105. x is equal to 75. So I got 75 degrees right here. Now, in order to figure out the triangle, to complete the angles of the triangle, I need the triangle sum theorem. 35 plus 75 plus my question mark is equal to 180. 5 plus 5 is 10. That's 10, but I have an extra 10, so I have 11. Plus the question mark is equal to 180. Subtract 110 degrees. And the question mark is equal to 70 degrees. So that's 70 degrees. Now, I want to show you a couple different... When you're going through this, I don't want to show how to do every single problem because then that's just me doing your homework. But I want to show you some ideas. This problem, number 12 here, I call a bow tie problem. And the nice thing about a bow tie problem is you always know that these two angles are equal to each other because they're vertical angles. Before you work on a triangle sum theorem, or before you work on an exterior angle theorem, unless that's the first theorem that pops off the page at you, you're looking for linear pairs and you're looking for vertical angles. And you start with that. So there you have vertical angles. You can do a triangle sum, get this angle, get that angle, then another triangle sum, and you're good to go. So you're going to end up with that. Now, one of the biggest and most common mistakes that I saw was that this is 90 degrees, but this doesn't cut it in half. So we can't assume that this is just going to be 45 and 45. We actually have to find out what this angle is. And so you add these to 84 plus 36 plus x is equal to 180, because that's going to be for this triangle right here. And so you get 10, you get 120 plus x equals 180. A little mental math tells me that's 60 degrees. So that's 60 degrees. But now, since we know that's 90 degrees, this value here, y, we could say y plus 60 degrees is equal to 90 degrees. Not 990 degrees. So y is equal to 30 degrees. So now you have 30 degrees over here, or you could have just done some mental math. Trust me, you are going to get used to doing these types of problems, and when it's 90 degrees, 160, 130. It's going to be one of those things that's just going to come right off the page at you. Now, I'm not going to solve that one for you, but it'll get you started. Now, for this, I see an exterior angle. And I know the exterior angle is going to be equal to these two angles added together. Here I see an exterior angle, or here I see an exterior angle. This exterior angle, the angle that we want, is this angle right here and this angle right here. I got 90 degrees right there. I can figure out what x is. I can use 90. I can figure out what that guy is. And then I can use a linear pair here to figure out what that angle is. And I can figure out what the question mark is at that point. So everything is, look for linear pairs. Like for this case right here, linear pair. Look for vertical angles. Vertical angles. Alright, I got two vertical angles. I got a linear pair. I can figure out what that guy is. I could just essentially say 180 minus 156, and that's going to give me this angle. Use the triangle sum theorem to figure out what this angle is. That'll give me this angle. And then the triangle sum theorem, or you can use the exterior angle theorem. So you can go two different routes at that point. Remember, you can go either with the exterior angle theorem or the triangle sum theorem at that point. Some fun problems like this. Again, this angle's 45, this angle's 45. That's angle 75, that's 75 degrees. Now all of a sudden, I have two angles in my triangle. And I can use the triangle sum theorem to get this angle. And this is like the problem we did earlier, where all three of these are 180 degrees. So I can figure out that angle. And then now I have two remote interior angles to find my exterior angle. Or you could use the triangle sum theorem and then get the linear pair. So there's a lot of different ways that you can go about doing that. But again, I stress, the four things you need: linear pair, vertical angles, then you move on to exterior angle theorems and triangle sum theorems. So the more complex the problems get like this, one, check for vertical angles. Two, check for linear pairs. Then 3a and 3b, you're going to get the triangle sum theorem. Or you're going to look for an exterior angle theorem. And you're going to move from there. So always look for vertical angles and linear pairs because those are your easy ones. Those are the easy ones that you can get right off the bat. And then you can move on from there. And that gets you through the first 16. They don't get a lot harder than that. The only problems that you're going to run into are when you have, like, I'll do this one. I'll do number 23. Just because it's really crazy. When they start throwing variables at them, don't worry about it. It's just variables. So if I know that this angle here is 8x plus 4, first thing I look for are vertical angles. This guy is equal to 8x plus 4. Now, I'm going to show you something really, really cool. You get 3x minus 6 because these are, now you have an exterior angle, which says the exterior angle is going to be equal to these two angles added together. So 3x plus 6 plus 8x plus 4 is equal to 130. And since the directions find the measure of angle A, there's the measure of angle A, I need x in order to find the measure of angle A. So if I do this by hand, I get 11x because I add my x's. 3x plus 8x is 11x. Then I have negative 6 plus 4, that's a negative 2, is equal to 130. Add 2. And I get 11x is equal to 132. And I know this is going to be x is equal to 12. I know it's equal to 12 because 11 times 11 is 121. And this is 11 more than 121. So I know it's going to be a 12. So now I know the measure of angle A is going to be 3 times 11 minus 6, which is 33 minus 6, which is something that everyone can learn from because, remember, x isn't what we're solving for. Although a lot of people think that once you get x, you're done. Once you get x, you're about 75% of the way there. And so this is 27 degrees. Now, the other cool thing that I wanted to show you has to do with your calculator. And I'm going to have to move everything up here, turn this on, and you're in a calculator screen. So I'm in the calculator screen now. I shall focus. Zoom out. Since our wonderful districts spend a ton of money on this, we might as well know how to use them to their fullest extent. Hit your menu button. one of the neat things, remember what we're in. We're in basically an algebra-based geometry class. So if I go down to algebra, it'd be 3. There's something called numeric solve. And hopefully you learned about this last year. But if you didn't, here it is. Numeric solve solves equations. I will type in 3x minus 6 plus 8x plus 4, and that's going to be equal to, and the equal sign is right next to the 7. Well, not right next to it, but over from the 7. And that's equal to 130. Now, the calculator is very, very smart if you tell it what to do. It doesn't know what to do unless you tell it what to do. I can give it an equation, and even though we know that we're solving for x, we have to give those instructions to the calculator, solve for x. So in order to solve for x, we have to say comma x. And comma's down in the keyboard side of it. It's the last key on the left. We go comma x, and I got my 12, which is what I got over here. So now, another cool thing is, you could have said, all right, I know I'm going to have to use this again. Over here where it says variable, there's a stow key. That means store. And you can think of A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, all the way up through W as a box. And that box can hold numbers. So what I want to do is, I want to hit Control Store, which is a small little arrow, and I'm going to put A. Because now, whenever I type in the number A, it's equal to 12. And so, if I see 3x minus 6, I just have to say 3a minus 6. I got my answer of 30. So you don't have to actually remember and to type things down. The only thing that I suggest is that if you're going to do this, that when you type this in and you say comma x, make sure you label the variable that you're going to use. Otherwise, you'll forget what is where, and then you have to look for it, and then that defeats the whole purpose of doing it. But other than that, that's a pretty good start on all these problems.